Space debris, tracking and managing orbital junk. Title: Space debris, tracking and managing orbital junk. Introduction, 150 words. As humanity continues to explore and expand its presence in space, a growing concern emerges: space debris. Space debris, also known as orbital junk or space junk, refers to the defunct satellites, spent rocket stages, and fragments resulting from collisions and explosions in space. This accumulation of discarded objects poses a significant threat to operational spacecraft and satellites, as well as future space missions and astronauts. To mitigate this risk, various organizations and space agencies around the world are actively involved in tracking and managing orbital junk. In this article, we will explore the challenges posed by space debris and delve into the methods and technologies used to monitor, track, and minimize its impact. Understanding the threat of space debris, 350 words. Space debris, consisting of both natural and human-made objects, orbits Earth at high velocities. The risks associated with space debris are twofold: collisions and the Kessler syndrome. Accidental collisions with debris can damage operational satellites, disrupt communication systems, and permanently disable valuable scientific instruments. Furthermore, these collisions generate secondary debris, exacerbating the problem and increasing the risk of further collisions. Tracking and monitoring space debris, 500 words. Precise tracking and monitoring of space debris are of paramount importance in order to develop effective strategies for its mitigation. Space agencies and organizations employ a combination of ground-based radars, telescopes, and satellite-based sensors to observe and track objects in orbit. Ground-based radars are essential for tracking larger pieces of debris. By bouncing radar signals off objects, scientists can determine their shape, size, and position. These systems are highly accurate and can effectively monitor larger debris in lower orbits. However, their capability to detect smaller objects is limited. Telescopes, both ground-based and space-based, play a vital role in detecting and tracking smaller pieces of debris, such as paint flecks or microsatellites. These telescopes use advanced optical technologies to spot debris and determine its trajectory. Satellite-based sensors, deployed on spacecraft, are crucial for tracking and monitoring space debris in real time. These sensors are equipped with advanced cameras and spectroscopic instruments that can identify and track smaller debris objects. Satellite-based sensors provide critical data for better orbital predictions and the tracking of dangerous debris. Mitigation strategies for space debris, 500 words. While tracking and monitoring provide important data, addressing the issue of space debris requires proactive and preventative measures. Space agencies and organizations have implemented several mitigation strategies to minimize the creation and growth of space debris. One such strategy is the implementation of strict mission planning guidelines, ensuring that satellites and rocket stages are removed from valuable orbits after they have completed their operations. These guidelines include measures like deorbiting or transferring satellites to safe graveyard orbits where they pose minimal risk to operational spacecraft. Another method being explored is active debris removal, ADR, techniques. These involve capturing and removing large and potentially harmful pieces of debris from orbit. This concept is still in its infancy, with various proposed techniques like nets, robotic arms, and harpoons being developed and tested for their efficiency and viability. ADR technology holds promise for reducing the risk posed by existing debris and mitigating the potential for future catastrophic collisions. Space debris has become a growing concern as humanity explores and expands its presence in space. also known as orbital junk or space junk. It refers to defunct satellites, spent rocket stages, and fragments resulting from collisions and explosions in space. The accumulation of discarded objects poses a significant threat to operational spacecraft, satellites, and future space missions and astronauts. To mitigate this risk, various organizations and space agencies around the world are actively involved in tracking and managing orbital junk. Understanding the threat of space debris is crucial. With more than 26,000 objects larger than 10 centimeters currently being tracked and countless smaller fragments, the presence of space debris poses a serious hazard. Collisions with debris can damage operational satellites, disrupt communication systems, and disable valuable scientific instruments. These collisions also generate secondary debris, worsening the problem. If left unchecked, the continual growth of space debris can create a self-sustaining cascade known as the Kessler syndrome, making space activities increasingly hazardous. Precise tracking and monitoring of space debris is vital to develop effective mitigation strategies. Space agencies and organizations use ground-based radars, telescopes, and satellite-based sensors to observe and track objects in orbit. Ground-based radars can track larger debris accurately but struggle to detect smaller objects. Telescopes, both ground-based and space-based, play a crucial role in tracking smaller debris. Satellite-based sensors, deployed on spacecraft, provide real-time tracking data for better orbital predictions. Addressing the space debris issue requires proactive measures. Mission planning guidelines ensure that satellites and rocket stages are removed from valuable orbits after completing their operations. Active debris removal (ADR) techniques are being explored, involving capturing and removing large and potentially harmful debris pieces from orbit. Various methods such as nets, robotic arms, and harpoons are being developed and tested for their efficiency. ADR technology holds promise for reducing the risk of existing debris and preventing future collisions. Space debris, also known as orbital junk or space junk, has become a growing concern as humanity explores and expands its presence in space. It refers to defunct satellites, spent rocket stages, and fragments resulting from collisions and explosions in space. The accumulation of these discarded objects poses a significant threat to operational spacecraft, satellites, and future space missions and astronauts. To mitigate this risk, various organizations and space agencies around the world are actively involved in tracking and managing orbital junk. Understanding the threat of space debris is crucial in order to develop effective mitigation strategies. Currently, more than 26,000 objects larger than 10 centimeters are being tracked, along with countless smaller fragments. The presence of space debris poses a serious hazard as collisions can damage operational satellites, disrupt communication systems, and disable valuable scientific instruments.